Hey there, cosmic wanderers. Welcome to the sleepy cosmos. I'm your guide through tonight's gentle journey into the most peaceful secrets our planet holds. If you're settling in with us right now, you're joining a family of dreamers and thinkers from every corner of the globe, all connected by our shared wonder for the quiet miracles happening beneath our feet and above our heads. Tonight isn't about explosive supernovas or violent cosmic collisions. Instead, we're diving into Earth's most beautifully soothing processes, the kind of facts that work like a cosmic lullaby, designed to calm your mind while expanding it at the same time. So grab your favorite blanket, maybe a warm drink, and let's explore 11 Earth facts so wonderfully calming that they might just be the gentle voice that finally helps you drift into peaceful sleep. Deep beneath the surface where you rest tonight, approximately 1,800 miles below your peaceful position, lies one of the most extraordinary and soothing phenomena in our solar system. Earth's liquid iron outer core, slowly and methodically generating the planet's magnetic field in a rhythm so steady and reliable, it's like listening to the gentle heartbeat of our world itself. This isn't just any ordinary magnetic field, but a protective embrace that has been quietly operating for over 4 billion years, never faltering, never taking a break, just continuously wrapping our entire planet in an invisible shield that extends far beyond our atmosphere into the vastness of space. The process itself is beautifully meditative. Imagine vast rivers of molten iron and nickel, heated to temperatures of nearly 6,000 degrees Celsius, flowing in slow, graceful convection currents that rise and fall like the most patient cosmic dance you could ever witness. These currents don't rush or hurry. They move with the deliberate, unhurried pace of geological time, taking thousands of years to complete their circular journeys through the outer core, each movement contributing to the steady generation of electric currents that birth our magnetic field. As Earth rotates on its axis once every 24 hours, these flowing currents get twisted and organized by what scientists call the Coriolis effect, creating beautiful spiral patterns that flow like liquid metal tornadoes, but moving so slowly that if you could somehow observe them, they would appear as still as a peaceful lake on a windless evening. What makes this process so wonderfully calming is its incredible consistency and reliability. While everything else in our lives changes rapidly, while storms rage and seasons shift, while technology evolves and civilizations rise and fall, deep beneath us, this ancient rhythm continues exactly as it has for billions of years, generating a magnetic field that ranges from 22,000 to 67,000 nanotesla in strength, which sounds impressive until you realize that this gentle field is actually about 50,000 times weaker than the magnet holding your photos to your refrigerator. Yet despite its gentleness, this whisper-soft magnetic embrace extends approximately 65,000 kilometers into space on the side facing the sun, and stretches even further on the nighttime side of Earth, creating what scientists call the magnetosphere, essentially a magnetic bubble that surrounds our entire planet like the most protective, invisible blanket imaginable. The magnetosphere doesn't just sit there motionless. It gently deflects the solar wind, a stream of charged particles constantly flowing from the sun at speeds of several hundred kilometers per second, redirecting these particles around Earth, rather than letting them strip away our precious atmosphere the way they did to Mars millions of years ago. The interaction between the solar wind and our magnetic field creates patterns so beautiful and peaceful that they manifest as one of nature's most soothing light displays. The aurora borealis in the north and aurora australis in the south, where curtains of green, blue, red, and purple light dance silently across the polar skies for hours at a time. These auroras are essentially our planet's magnetic field made visible, and watching them is like observing Earth's protective energy in action. Charged particles from the sun, guided along magnetic field lines, gently collide with oxygen and nitrogen molecules in our upper atmosphere at altitudes between 80 and 500 kilometers above the surface. When these collisions occur, they excite the atmospheric molecules, causing them to release photons of light in specific colors. Oxygen produces the familiar green glow at around 558 nanometers and red emissions at 630 nanometers, while nitrogen contributes blue and purple hues, creating a natural light show that operates without sound, without violence, just pure, gentle luminescence that can continue for entire nights during periods of increased solar activity. The timing and intensity of auroras follow the 11-year solar cycle, waxing and waning with the sun's activity like a cosmic breathing rhythm, sometimes visible only in the far northern and southern regions, and occasionally, during particularly active solar periods, extending their peaceful glow far enough south that people in northern United States or northern Europe can witness Earth's magnetic field painting the sky with its protective colors. What's particularly soothing about auroral displays is their unpredictable yet rhythmic nature. They can appear suddenly and dance for minutes or hours, creating shifting curtains and spirals of light that move with fluid grace, never harsh or jarring, always flowing like silk scarves in a gentle breeze, then fade away just as peacefully as they appeared, leaving observers with a sense of having witnessed something both scientifically magnificent and deeply calming. The magnetic field that creates these beautiful displays has been protecting Earth for so long that it predates not only human civilization, but complex life itself. Recent research analyzing ancient zircon crystals from Australia, some of the oldest materials on Earth, has revealed magnetic signatures indicating that our protective field existed at least 4.2 billion years ago, when our planet was still young and the inner core hadn't even formed yet. This means that during Earth's entire history of developing life, from the first simple bacteria to the complex ecosystems of today, this gentle magnetic shield has been quietly operating, maintaining the stable atmospheric conditions necessary for biological evolution to proceed at its own unhurried pace. The field has experienced changes over these vast timescales. It has weakened and strengthened, and the magnetic poles have even reversed their positions hundreds of times throughout Earth's history, with north becoming south and south becoming north during periods that last thousands of years. Yet through all these changes, the essential protective function has remained constant. Scientists have discovered that the magnetic field follows a roughly 200 million year cycle of strengthening and weakening, like an incredibly slow pulse that beats in harmony with deep Earth processes we're only beginning to understand, connecting the rhythm of our planet's core to cycles that span geological eras. During times when the field is stronger, Earth receives enhanced protection from cosmic radiation, while weaker periods still provide adequate shielding, but allow more charged particles to reach the upper atmosphere, creating more frequent and intense auroral displays. Essentially, a weaker magnetic field means more opportunities to witness Earth's protective energy made visible in the polar skies. Currently, scientists monitoring Earth's magnetic field have noticed that it has been gradually weakening over the past few centuries, declining at a rate of about 5% per century, which might sound concerning, but actually represents a perfectly natural fluctuation in Earth's magnetic rhythm. The field has been much weaker in the past and has always recovered, continuing its ancient duty of protecting our planet's atmosphere and the life it sustains. The gradual weakening we're experiencing today simply means that we're living during a time when auroras might become more frequent and visible at lower latitudes, offering more people the opportunity to witness the gentle dance of Earth's magnetic field across the night sky. What remains constant, regardless of these natural fluctuations, is the steady, reliable generation of the field itself. Deep in Earth's core, those ancient convection currents continue their patient circulation, driven by the gradual cooling of the inner core and the rotation of our planet, creating electric currents that generate magnetic fields with the same methodical persistence that has characterized this process for over 4 billion years. This is perhaps the most calming aspect of Earth's magnetic heartbeat: its absolute reliability, its ancient rhythm that connects us to the very beginning of our planet's story, reminding us that we live within a protective embrace that has been gently sustained since before life itself existed and will continue long after we're gone. A cosmic constant that beats with the patient rhythm of geological time, steady as a sleeping planet's breath, reliable as the rotation that brings each peaceful night and day. Beneath the familiar surface, waves that lap peacefully against shorelines around the world, there exists a hidden network of ocean currents so vast and slow-moving that they make our planet's entire climate system possible while remaining almost completely invisible to us as we go about our daily lives. These are not the rapid, wind-driven surface currents that carry surfers and sailboats, but something far more profound and calming: a system of deep, methodical circulation patterns that scientists have lovingly nicknamed the Great Ocean Conveyor Belt, or Global Conveyor Belt. Massive rivers of seawater that flow through the deepest parts of our oceans at speeds so gentle they make a leisurely stroll seem hurried by comparison. This thermohaline circulation, driven by subtle differences in temperature and salinity that create barely perceptible changes in water density, moves at an average speed of just 10 centimeters per second, slower than you walk when you're trying to be quiet in the morning so you don't wake anyone. What makes this slow motion dance of ocean waters so beautifully calming is not just its unhurried pace, but the incredible journey each drop of water takes as it travels through this global system. A journey so long and peaceful that it can take between 1,000 and 1,500 years to complete a single circuit around all of Earth's ocean basins. Imagine water that began its deep ocean journey during the time of medieval castles and knights, slowly and silently making its way through the depths, only now beginning to see sunlight again as it rises to the surface in some distant part of the Pacific Ocean. The journey of this great oceanic circulation begins in one of Earth's most serene and pristine locations: the cold, clear waters near Greenland and Iceland in the North Atlantic, where the interaction between ocean and atmosphere creates conditions so perfect for deep water formation that it's like witnessing the planet's own meditation on the concepts of patience and persistence. Here, in the Norwegian Sea and surrounding waters, something magical and deeply calming occurs during the winter months when cold Arctic winds blow across the ocean surface, causing water molecules to evaporate into the dry air above. As pure water evaporates, it leaves behind its dissolved salts, making the remaining seawater gradually more saline and therefore denser, while the cold temperatures further increase this density until the water becomes heavy enough to sink slowly toward the ocean floor. This process, called evaporative cooling, happens so gradually and gently that individual water parcels sink at rates measured in just centimeters per day, like the most patient, methodical elevator ride imaginable, carrying dissolved oxygen, nutrients, and the memory of sunlight down into the deep Atlantic basin, where they join the vast body of water that oceanographers call North Atlantic deep water. This newly formed deep water doesn't rush or tumble. Instead, it flows southward through the deep Atlantic with the stately pace of geological time, following pathways carved by underwater mountain ranges and guided by the subtle influence of Earth's rotation, which gently nudges the current westward as it moves toward the equator. As this deep water continues its unhurried journey southward through the Atlantic, it eventually reaches the Southern Ocean around Antarctica, where it encounters an even denser water mass called Antarctic bottom water, formed through similar processes of cooling and salt concentration, but made even heavier by the extreme cold of Antarctica's coastal waters and the additional salt excluded during sea ice formation. Rather than mixing turbulently, these two water masses interact with the grace of dancers, with the denser Antarctic water gently sliding beneath the North Atlantic deep water, creating distinct layers that maintain their individual characteristics for decades as they flow together through the deep ocean basins. The combined waters then join the Antarctic Circumpolar Current, the only current that flows completely around the globe, creating what might be considered the most peaceful expressway in the ocean, a slow-moving ring of water that circles Antarctica like a vast liquid meditation wheel, taking about 8 years to complete each revolution while connecting the Atlantic, Indian, and Pacific Oceans in one continuous, unhurried flow. From this Southern Ocean junction, the deep waters split into different branches, with some flowing northward into the Indian Ocean basin and others making their way into the vast Pacific, carrying with them the chemical signatures of their origins, high oxygen content, and low nutrient levels that mark them as relatively young waters that haven't been separated from the atmosphere for very long. The branch that flows into the Indian Ocean begins a particularly peaceful part of the global circulation, moving northward through deep ocean basins while gradually warming and slowly exchanging some of its dissolved chemicals with the waters above and below. This vertical mixing happens so gently that it's measured in millimeters per day, like the world's most patient stirring process, gradually transferring nutrients from the deep waters upward and bringing oxygen-rich water downward in a process that helps maintain the chemical balance necessary for deep-sea life. Some of the Indian Ocean deep water eventually makes its way to the surface through equally gentle upwelling processes, particularly in areas where trade winds consistently blow surface waters away from the coastlines, allowing deeper waters to slowly rise like an incredibly gradual elevator, bringing nutrients that have been stored in the deep ocean for decades back to sunlit surface waters where they can support marine ecosystems. The surface water that forms from this upwelling doesn't stay in the Indian Ocean. Instead, It becomes part of a warm surface current system that flows westward across the tropical Indian Ocean, around the southern tip of Africa, and then northward through the Atlantic as part of the Gulf Stream system, completing one arm of the global conveyor belt circulation. Meanwhile, the Pacific branch of the deepwater circulation follows an even more epic journey, flowing northward through the deepest parts of the Pacific Basin at depths of 2,000 to 4,000 meters below the surface, so far from sunlight that these waters exist in a realm of perpetual, peaceful darkness where temperatures hover just above freezing and the pressure is hundreds of times greater than at the surface. These Pacific deep waters become the oldest waters on Earth, some spending over 1,000 years in the deep ocean before eventually rising to the surface in the North Pacific, carrying with them a chemical record of their long journey. They've gradually accumulated nutrients from the slow decay of organic matter that sinks from the surface, while their oxygen content has been slowly depleted by deep-sea organisms, creating water that is among the most nutrient-rich and CO2-rich in the world's oceans. When these ancient waters finally reach the surface through gentle upwelling processes along the coasts of the Pacific, they bring with them the accumulated wisdom of their thousand-year journey, supporting some of the most productive marine ecosystems on Earth with nutrients that have been patiently transported across entire ocean basins. The upwelling process itself is beautifully gentle. Rather than erupting dramatically, these deep waters rise at rates of just a few meters per day, slowly ascending through the water column like air bubbles rising through honey, bringing their cargo of nutrients gradually into the sunlit surface waters, where microscopic marine plants can finally use them for photosynthesis. What makes this global ocean circulation so profoundly calming to contemplate is not just its unhurried pace, but its absolutely crucial role in maintaining Earth's climate stability. This slow-moving system transports approximately 1.5 billion tons of water per second around the planet, which sounds enormous until you realize that this represents just a gentle, steady flow that has been operating with remarkable consistency for millions of years. The conveyor belt carries about 25% of all the heat that gets transported from tropical regions toward the poles, making it one of Earth's most important climate-regulating mechanisms. Yet it does this job so quietly and steadily that most people never think about it. In the North Atlantic, this circulation system is responsible for keeping European temperatures about 5 to 10 degrees Celsius warmer than they would be otherwise, creating the temperate climates that allow places like London and Paris to remain green and habitable despite being at latitudes similar to frigid Labrador. The system works like an enormous, slow-motion heat pump, continuously drawing warm tropical surface water northward through currents like the Gulf Stream, then allowing this water to release its heat to the atmosphere over northern Europe before cooling, sinking, and beginning the deep return journey southward. This heat transport happens so gradually and consistently that it creates a kind of oceanic thermostat for the planet, helping to moderate temperature extremes and maintain the stable conditions that have allowed complex life to evolve and flourish for millions of years. Perhaps most remarkably, this vast circulation system operates with the kind of reliability that makes it the ocean's equivalent of Earth's magnetic field. It has been running continuously for millions of years, powered entirely by the gentle, natural processes of solar heating, evaporation, and cooling that require no external energy input beyond the sun's steady radiation. The system is so stable and self-regulating that even significant climate changes in Earth's past have only modified its strength and pathways rather than stopping it entirely, demonstrating a kind of planetary resilience that speaks to the deep wisdom embedded in natural systems. Current research suggests that while the circulation may be gradually slowing due to climate change, fresh water from melting ice sheets is making North Atlantic surface waters less dense and therefore less likely to sink. The system shows remarkable persistence and will likely continue operating in some form for millennia to come, adapting to changing conditions with the same patient flexibility it has shown throughout Earth's history. This gives the global ocean conveyor belt a quality of eternal patience, like a vast, liquid meditation on the themes of persistence, interconnection, and the gentle but inexorable power of slow, steady processes to shape our world in the most fundamental and life-sustaining ways. Tonight, as you settle into peaceful rest, something extraordinary and deeply calming is happening all around our planet. Mountains are growing, rising imperceptibly slowly toward the sky at rates so gentle that they make the most patient gardener seem hurried by comparison. This mountain-building process, which geologists call orogeny, operates with a kind of unhurried persistence that would make ancient monks envious, lifting entire mountain ranges millimeter by millimeter through geological processes so gradual that a single human lifetime represents barely a blink in their magnificent journey toward the heavens. While you sleep peacefully tonight, the Himalayas will grow approximately 0.01 millimeters taller, a measurement so small it would take sensitive scientific instruments to detect. Yet over the course of 1,000,000 years, this patient accumulation creates some of the most breathtaking peaks on Earth. What makes this process so wonderfully soothing to contemplate is not just its incredible slowness, but the gentle, persistent way that enormous geological forces work together in perfect harmony, like a planetary symphony played in the key of deep time, where each note lasts for centuries, and the complete movement spans millions of years. The mountain-building process begins deep beneath the Earth's surface with the slow, methodical movement of tectonic plates, massive slabs of rock that drift across our planet's surface at speeds roughly equivalent to the rate your fingernails grow, typically between 2 to 10 centimeters per year. These tectonic plates don't rush or collide violently in their everyday movements. Instead, they engage in what can only be described as the most patient dance in the universe, sliding past each other, pulling apart, and gradually converging over periods measured in millions of years. When two tectonic plates meet at what geologists call a convergent boundary, they don't crash together like cars in an accident, but rather press against each other with slow, steady pressure that builds over geological ages, creating stress within the Earth's crust that accumulates so gradually that the rocks themselves have time to respond by bending, folding, and ultimately rising upward in the most graceful, slow-motion ballet imaginable. This convergent process is particularly beautiful when it involves continental plates, as is happening right now along the boundary between the Indian and Eurasian plates, where the Indian subcontinent continues its incredibly slow northward journey that began over 50 million years ago, moving at roughly the same pace as the mid-Atlantic ridge spreads, about 2.5 centimeters per year. The Himalayan mountain range, including Mount Everest, represents perhaps the most perfect example of how these gentle geological processes can create something truly magnificent over deep time. The collision between India and Eurasia began around 50 to 55 million years ago, when the Indian plate, carrying what would become the Indian subcontinent, began its slow motion approach toward the southern edge of the Eurasian landmass. Rather than one plate simply sliding beneath the other, as happens in oceanic subduction zones, both continental plates proved too buoyant to sink into the Earth's mantle, creating a situation where the only way to accommodate the continuing convergent motion was for the crust to thicken and rise upward. This process, called continental collision, represents mountain building at its most serene and persistent. Imagine the Indian subcontinent as an incredibly slow-moving steamroller, approaching Eurasia at a pace so gentle that if you could somehow observe it from space over millions of years, it would look like two massive pieces of land embracing each other in the world's longest, most patient hug. The sediments that once lay peacefully on the ancient ocean floor between these two land masses were gradually scraped up and compressed, like frosting being squeezed between two pieces of cake pushed together in extreme slow motion, eventually forming the towering peaks that now define the Himalayan range. What makes the current growth of the Himalayas so particularly calming to consider is the remarkable consistency of the process. These mountains have been rising at approximately the same gentle rate for millions of years, with uplift rates that typically range between 1 to 10 millimeters per year, depending on the specific location within the range. Mount Everest itself grows taller by roughly 4 millimeters annually, which means that in your entire lifetime, this magnificent peak will gain approximately 30 centimeters in height, about the length of a ruler, through the patient accumulation of nearly imperceptible daily growth. This growth doesn't happen through sudden, dramatic events, but rather through the continuous, gentle pressure of tectonic convergence that operates like the world's most persistent but gentle massage, slowly kneading the Earth's crust upward, grain by grain, crystal by crystal, in a process so gradual that the rocks themselves can accommodate the stress through slow deformation rather than sudden fracturing. The beautiful aspect of this mountain growth is that it occurs simultaneously with erosion. As the peaks rise slowly skyward, weather and water work just as patiently to wear them down, creating a dynamic equilibrium where mountains grow and erode in a perfectly balanced dance that maintains their general height and character over geological time. The formation of fold mountains, like many of the ranges in the Alps, Appalachians, and Himalayas, represents one of nature's most graceful responses to tectonic pressure. Rather than breaking suddenly under stress, the rock layers within the Earth's crust respond by bending and folding like sheets of paper being gently compressed in slow motion. These folds can be enormous, with wavelengths measured in kilometers and amplitudes that reach thousands of meters in height. Yet they form through such gradual processes that individual rock layers maintain their integrity while being shaped into beautiful, sweeping curves that can take millions of years to complete. The process of folding happens so slowly that sedimentary rock layers originally deposited horizontally on ancient seafloors can be twisted into vertical positions, with some formations even being folded over completely so that older rocks end up lying on top of younger ones, all accomplished through the patient application of tectonic forces over time spans that dwarf human civilization. What's particularly soothing about fold mountain formation is how it demonstrates the Earth's incredible capacity for gradual change. Rather than sudden, catastrophic deformation, the planet's crust responds to stress with the kind of slow, graceful adaptation that allows for the creation of some of the world's most beautiful and enduring landscapes. Block mountains, also known as fault block mountains, form through an equally gentle but different process where sections of the Earth's crust gradually rise or fall along fracture lines called faults, creating the stepped, plateau-like landscapes found in regions like the Sierra Nevada in California, or the Basin and Range Province of the western United States. These mountains don't thrust upward suddenly. Instead, they rise through the slow, methodical process of crustal blocks tilting and shifting along fault planes over periods of millions of years, with typical uplift rates measured in fractions of millimeters per year. The movement along these faults happens so gradually that forests, rivers, and entire ecosystems can maintain their existence on the slowly rising blocks, adapting to the gentle changes in elevation and climate that occur over geological time. This type of mountain building creates some of Earth's most peaceful and stable landscapes, where broad, flat-topped ranges rise gradually from surrounding valleys through processes so gentle that they barely disturb the natural systems living on their surfaces. Perhaps most remarkably, modern scientific research has revealed that mountain building operates at even deeper levels within our planet, with recent studies showing that the growth and height of mountain ranges may be controlled not just by surface tectonic processes, but by incredibly slow and gentle flows within the Earth's mantle, the layer of hot, slowly moving rock that lies between the crust and the core. These mantle flows operate on timescales of tens of millions of years, moving like incredibly viscous honey through the deep interior of our planet, gradually carrying less dense material upward and allowing denser material to sink downward in a process called compositional differentiation that helps build the continental crust that forms mountain ranges. The discovery that deep mantle processes may be the primary driver of mountain uplift represents a beautiful example of how the Earth operates as an integrated system, where the deepest, most patient processes in our planet's interior ultimately express themselves as the magnificent mountain ranges we see at the surface. This connection between the Earth's deep interior and surface topography operates through such slow, gentle processes that mountains can be thought of as the planet's way of slowly exhaling, releasing the gradual buildup of thermal and chemical energy from the deep earth through the patient process of crustal uplift and mountain building. As you drift off to sleep tonight, you can take comfort in knowing that this ancient, gentle process continues all around the world, silently and persistently creating the magnificent landscapes that have inspired human cultures for millennia, all through the power of slow, steady processes that demonstrate the Earth's infinite patience and its capacity to create beauty through the simple accumulation of tiny changes over vast spans of time. Imagine the Earth as a living, breathing organism, ancient and infinitely patient, inhaling and exhaling through cycles so slow and gentle that their rhythms span millions, sometimes even billions, of years. Tonight, as you rest and listen, you are part of this deep planetary breathing, supported by the quiet regulation of carbon moving between rocks, air, ocean, and life. Scientists call this the global carbon cycle, and it is one of the most soothing, harmonious processes to contemplate, not just for its importance, but for its sheer sense of calm and longevity. At its core, the carbon cycle is the planet's way of keeping the atmosphere balanced, maintaining levels of carbon dioxide that allow temperatures to remain stable enough for life to flourish. Unlike human breathing, which happens dozens of times a minute, Earth breathes in eras, geological epochs in which mountains grow, erode, and regrow, where continents drift and collide, where oceans form and evaporate, and where living things claim carbon from air, store it away, and return it gently with their passing. This breathing is the ultimate in slow and gentle regulation. As you sink into relaxation and consider the world around you, realize the air you inhale tonight contains molecules that have cycled through deep rock, ancient forests, and the oceans multiple times, over unimaginable timescales. The slowest part of this process happens deep underground, where carbon is stored in solid rock, limestone, dolomite, fossil fuels, trapped through processes that typically unfold over millions of years. Rainwater, carrying dissolved carbon dioxide, seeps slowly through rivers and streams, eventually percolating into the soil and rock, there to react with minerals in small, nearly invisible increments. These reactions are the very definition of patience. Carbon is locked into rock at a rate so gradual that it would take a geological epoch to notice the difference. But collectively, these reactions shape the planet over time. Volcanoes offer occasional exhalations, releasing stored carbon back into the atmosphere when pressure and temperature allow it. But on the whole, the processes of weathering and carbon storage are staggeringly slow, deliberate, and calm. Living things also play their part in this planetary rhythm. Plants settle quietly across the landscape, drawing in carbon dioxide and gently storing it as part of their bodies. When they die, much of the carbon returns to the soil, where it can stay for centuries or millennia, only gradually released through decay or fire, or the slow respiration of bacteria and fungi. Forests act as gentle carbon sponges, soaking up the excess and helping to keep the planetary breathing balanced, even as their individual trees come and go. Coral reefs, algae, and plankton do the same in the oceans, capturing carbon, forming limestone shells, and eventually sinking to the ocean floor, where their remains form sediment that can be locked away for millions of years. The ocean, with its vast dark depths, is Earth's largest carbon reservoir, holding far more carbon than the air or land combined, and releasing it in careful, measured breaths that take centuries or more. Weathering, the slow, almost imperceptible breakdown of rocks at the surface by water, freezing, and biological activity, is another essential piece of this deep planetary metabolism. It is the slowest and most unspectacular of all geological processes, yet it is quietly powerful, gradually grinding mountains into plains, releasing minerals and capturing carbon to be stored as new rocks or dissolved into the ocean. Even the growth of plant roots, inching their way into cracks and crevices, contributes to the restful, continuous reshaping of the planet's face over eons. This weathering grinds down high places, but does so with infinite patience. Each particle moved, each fragment released, is a tiny step in the planet's slow journey toward equilibrium, part of a process that is always happening and always invisible to the hurried eye. Occasionally, the Earth's breathing becomes visible. An eruption, a burst of plankton in spring, a bloom of green covering the mountains after rain. But mostly, the steady inhalation and exhalation of the carbon cycle is invisible to us, operating in the background, quietly balancing the atmosphere and nurturing the planet's living systems. The processes may be slow, but their long-term effects are profound. Over time, this delicate balance of absorption, storage, and release has kept the Earth's climate stable enough for multicellular life to thrive. Even dramatic events like ice ages, volcanoes, or great extinctions only temporarily disrupt this deep, enduring pulse. The breathing eventually returns to its ancient rhythm, just as it has always done. As you drift further into sleep tonight, imagine the journey of a single carbon atom. Perhaps it began as volcanic rock, was slowly weathered into the sea, used by plankton, sunk into the depths, only to be lifted up by tectonic forces and exposed on land once more. Maybe it became part of a leaf or shell, spent decades in the body of a tree or coral, returned to the air in a gentle release, and began the cycle again. Every breath you take connects you directly to this ancient planetary process, uniting your life with that of the entire biosphere and offering a sense of peace rooted in the slow, steady breaths of the planet itself. This calm cycle of carbon is a fundamental part of Earth's ability to recover from shocks, maintain stability, and ensure that life has the time and gentle conditions it needs to adapt and flourish. Even as we notice changes due to human activity, the underlying rhythm persists, waiting patiently for the equilibrium to be restored over time. The deep geological breathing of the carbon cycle remains, a continual whisper of balance and resilience that envelops the planet in quiet harmony. Let thoughts of this gentle, ongoing process ease your mind. Rest in the knowledge that Earth's breathing, though slow and ancient, supports you along with every living thing, offering the ultimate reassurance in its unwavering patience and enduring calm. Tonight, as you drift toward gentle sleep, picture Earth beneath you as a patient artist, quietly crafting structures of beauty and symmetry in places far removed from daily noise. A world where crystals and minerals slowly come into existence, perfect and still through processes that can take centuries, thousands, or even millions of years. This hidden world of crystal formation is an experience in pure tranquility. It begins deep underground, often in the calmest corners of the planet, where temperature, pressure, and chemistry combine in just the right measure to coax atoms into repeating patterns, growing one after another in a dance of microscopic regularity. Minerals are nature's geometry. They are built from elements like silicon, oxygen, carbon, and iron, atoms that become partners under the right conditions, forging bonds that create lattices, columns, cubes, and sheets. The slow cooling of molten rock, magma, beneath the surface gives birth to some of the most striking mineral crystals found on Earth. Granite, for example, is a beautiful result of this process. When magma cools slowly, atoms have time to arrange themselves into large, well-formed crystals like quartz, feldspar, and mica. The slow cooling is crucial. It can take thousands of years for a single chamber of magma to cool from molten heat to solid rock. And during this time, the crystal structures inside respond to even the smallest changes in temperature and pressure, growing with patient precision. In other, equally tranquil environments, minerals form from solutions. Water, filled with dissolved ions from rocks and soils, seeps through underground channels, collecting in pockets and voids. As environmental conditions shift, maybe a drop in temperature or a slow evaporation, the minerals in solution begin to crystallize. Halite, rock salt, gypsum, and calcite form this way. Some of these crystals take shape in beautiful clusters, visible in caves as still pools or hanging stalactites and stalagmites. These shapes grow so slowly that entire lifetimes might pass while a stalactite extends by a few centimeters. Such patience is the heart of mineral growth, a testament to time's gentle touch. The process is repeated everywhere, on every continent and under every sea. Gemstones, those dazzling flashes of color and light, come from these quiet repetitions. Amethyst, emerald, diamond, sapphire, all are built atom by atom in secluded pockets deep within the crust. Diamonds, for instance, start their journey hundreds of kilometers beneath the surface, where the weight of overlying rock and the heat of Earth's mantle combine for millions of years before bringing their crystalline form slowly upward, sometimes with the help of volcanic activity, but always beginning with the meditative patience of deep time. The symmetry and perfection of crystals arise from the orderly connections between their building blocks. As atoms come together, they create unit cells, a tiny, repeating module. When conditions remain peaceful and undisturbed, these modules replicate for countless cycles, eventually producing the visible faces and edges of minerals. The regularity is profound. Snowflakes, which freeze over minutes or hours, mimic this perfection. But a quartz crystal grown inside the earth follows the same laws of symmetry for thousands of years. Some minerals, like gypsum or calcite, form through evaporation in wet caves, building delicate spires and plates visible for centuries before shifting even slightly. These crystalline foundations are more than just pretty stones. They are the scaffolding for the world we know. When crystals lock together in igneous rocks, they create the strength to hold mountains and continents in place. When they dissolve in water, travel through groundwater, and precipitate somewhere new, they start over, building stability with enduring calmness and patience. Even soil, the foundation for all terrestrial life, is made possible by the slow weathering and rearrangement of minerals. Sand, clay, and silt form as crystals break, grind, and reform. Nature's endless cycle of gentle destruction and rebuilding. The movement of these minerals is quiet but essential. Plate tectonics drives continents together, lifting mountains and burying marine sediments. As rocks are pushed deeper, heat and pressure coax atoms into new crystalline arrangements. Metamorphic minerals like garnet, kyanite, or staurolite appear, each with its own perfect geometry, formed through lengthy, gentle change. The slow collapse and uplift of mountains allow for continual rearrangement, reshaping patterns and bonds in never-ending cycles over eons. Every crystal, no matter its origin, becomes a physical record of time, holding within its lattice the silent memory of pressures, temperatures, chemistry, and movement. Sometimes, the crystals make their way to the surface, exposed by erosion, river movement, or human hands, and display their symmetry in the sunlight. Each face, each edge, is the result of uninterrupted growth, a testament to peaceful persistence and the comfort of time's slow unfolding. Throughout history, civilizations have revered these crystals not only for their beauty, but for their quiet stability, used as guides for navigation, stones for shelter, tools for agriculture, and talismans of hope or healing. The breath of Earth's crystalline world is slow and endless. Minerals dissolve and grow. Crystals break and reform. Gems ascend through thousands of meters of rock. Sandstone and limestone accumulate, forming beds and layers for millions of years, only to be compacted and reborn as marble or slate. These changes are so profound and gradual that the bedrock beneath you, the stones lining rivers and valleys, may contain crystals billions of years old, older than any of Earth's living beings, and older even than some continents themselves. As you sink deeper into relaxation, let your thoughts follow the tranquil pathways of crystals forming beneath the surface. Imagine the steady, patient arrangement of atoms, each bond forging slowly, each shift a gentle adjustment, creating the perfection of a mineral's face or the gentle curvature of a cave's stalactite. In time, even the hardest rocks will yield, their crystals will move, and new foundations will emerge. This crystalline patience hums beneath us all, lending the world its quiet strength and eternal beauty. As dusk settles and a quiet calm takes hold, pause to feel the deep, rhythmic motion of our planet's rotation. A motion so subtle and soothing, so dignified and slow, that very few ever notice its majestic impact. The Earth is not simply spinning like a perfect top. It's performing an intricate wobble, a slow, grand dance called precession, which completes a full cycle every 26,000 years. This gentle cosmic medley, so patient and deliberate, combines the surprising softness of deep time with extraordinary stability, and understanding its grace can help settle restless minds and lull them into peace. Precession is the gradual shifting of Earth's rotational axis, the imaginary line running through the north and south poles, around which our planet turns each day. Unlike a rigid arrow, the axis traces out a slow, spiraling cone in space, meaning that very gradually the direction of north changes over thousands of years. If one could watch this from a cosmic distance, it would appear as if the planet's axis is slowly wobbling, reminiscent of a spinning top that doesn't just turn on itself, but also drifts its angle gracefully, centuries at a time. This slow wobble profoundly affects our relationship with the sky. The star Polaris, presently our North Star and reliable celestial marker, will not always remain so. In 12,000 years, Vega will become the North Star, and long before and after, other stars will take their turn. This cosmic ballet is driven mainly by gravity, the pull of our moon and the sun. As the planet spins, these bodies tug ever so slightly at its equatorial bulge, the result of Earth's rotation, causing the axis to tilt and trace its circular path. The process is delicate and precise. No sudden jolt shifts our orientation, only the most peaceful, slow adjustment, like the planet breathing through millennia. The pace is so gradual that within a single human life, the movement is almost unnoticeable, yet it is always running in the background, harmoniously shifting the canvas of night and day. Earth's wobble works together with other even slower changes, obliquity and eccentricity. Obliquity describes the tilt of the axis itself, which swings gently between about 22.1 and 24.5 degrees over a cycle of about 41,000 years. Eccentricity is a shifting of our planet's orbit, sometimes almost perfectly circular, sometimes more oval-shaped, a cycle that takes roughly 100,000 years. These are known together as Milankovitch cycles, a trio of cosmic patterns that guide the rhythm of ice ages, long-term climate stability, and the movement of the stars in the heavens above. All unfold with staggering patience, influencing winds and ocean currents, the migration of animals, and the shape of continents, but with such smoothness that the world remains tranquil for generations at a time. Throughout deep time, these slow orbital dances have shaped the fate of life itself. As precession shifts, so do the timing and intensity of seasons in different hemispheres. A quiet whisper that nudges the edge of each summer and winter, adjusting rainfall patterns and temperature balances, sometimes triggering great ice ages or warming periods, always in harmony with the gentle push and pull of gravity. The effects trickle down to the soil beneath us, to forests and deserts, to the rise and fall of kingdoms and cultures. Ancient astronomers were keen observers of the heavens, noticing small changes in the position of stars and the timing of planting seasons, all governed in part by the patient, silent precession of our home. One of the most comforting aspects of precession and its associated cycles is how gracefully the planet navigates these vast changes. Unlike lightning or earthquakes, sudden and unsettling, the wobble is a kind of slow cosmic lullaby, with uncertainty smoothed out over generations. It's a reminder that profound change need not occur in haste, but can be gentle, continuous, and woven with resilience. Even large climatic events, such as the transitions into and out of ice ages, are preceded by eons of subtle preparation, with ice sheets growing and retreating over tens of thousands of years. Life on Earth, including our own, is thus shaped not just by sharp shocks, but by the soft, persistent hand of time itself. Some scientists have described precession as the planet's way of resetting its orientation, offering new perspectives on the universe every cycle, gently shifting our view of the cosmos in a meditative, circular journey. Watching the stars change over generations, seeing the constellations slip gradually across the night sky, reminds humanity that even the heavens respond to the planet's deep patience. Imagine looking up at the sky, finding the North Star, and knowing that future children, long after we are gone, will gaze upon a different guiding star, brought to them steadily and serenely by this endless wobble, dance. This persistent celestial motion also fosters balance. If the axis were perfectly fixed, Earth's climate would be rigid, less forgiving, unable to adapt easily to slow changes in the cosmic environment. But with the wobble, the tilt, and the swing, our planet breathes through epochs, redistributing warmth and cold, sunlight and darkness with sublime grace. This provides the continuity that allows forests to adapt, ocean currents to shift, and biodiversity to remain rich across eons, never abrupt, always gradual. Let these thoughts draw you further into relaxation. Our world turns beneath an ancient choreography of cosmic forces, its axis drawing slow circles in the void, unfurling new vistas with infinite patience. Each day and night repeat as their own gentle heartbeat, but so too does each millennial cycle, shaping reality with a quiet power and giving life, your life, a place in an ongoing story much older and calmer than any daily worry. As you rest, know that this soothing cosmic dance continues beneath you, around you, and through the very fabric of existence, a source of endless comfort and sleep-inducing tranquility. As you settle deeper into this peaceful evening, let your mind drift to one of Earth's most soothing and predictable rhythms, the gentle, eternal dance of tides that has been flowing across our coastlines for billions of years, creating a quiet symphony that connects our planet to the cosmos in the most serene way imaginable. This isn't just the simple rise and fall of ocean water that you might observe during a beach walk. It's a profound gravitational conversation between Earth, Moon, and Sun that speaks in the language of patience, persistence, and perfect timing. Every single day, twice each day, our oceans breathe in this ancient rhythm, expanding and contracting like the planet's own meditation practice, a process so reliable that coastal communities have structured their lives around its gentle predictability for thousands of years. The moon, hanging serenely in our night sky at an average distance of 384,400 kilometers away, exerts its gravitational influence on Earth with such subtle grace that most people never stop to consider the invisible threads of force that connect these two celestial bodies in their eternal dance. This gravitational pull doesn't affect just one part of our planet. It embraces the entire Earth, tugging at every molecule of water in our oceans, every grain of sand on our beaches, even the solid rock beneath our feet. The strength of this pull varies across Earth's surface, being strongest on the side closest to the moon and weakest on the side farthest away, creating what scientists call a tidal force that gently stretches our planet into a very slight oval shape, elongated toward and away from the moon. This stretching is so gentle that the solid Earth deforms by only about 50 centimeters at most, but the liquid oceans, being far more responsive to gravitational influence, create the magnificent tidal bulges that we experience as high and low tides. What makes this process so beautifully calming to contemplate is how the moon's gravity doesn't simply pull water toward itself, but creates two tidal bulges simultaneously, one on the side of Earth facing the moon, where the gravitational pull is strongest, and another on the opposite side, where the pull is weakest. This dual bulge system might seem counterintuitive at first, but it represents one of nature's most elegant demonstrations of how forces work together in harmony rather than opposition. On the moon-facing side, the ocean water is pulled more strongly toward the moon than the solid Earth beneath it, causing it to bulge outward, while on the opposite side, the solid Earth is pulled more strongly than the water above it, leaving the water behind to form a second bulge. As our planet rotates beneath these two stable bulges, different coastlines pass through the high and low water regions, creating the familiar twice-daily pattern of tides that has soothed beachgoers and mariners for millennia. The timing of tides follows the moon's stately progress across our sky, but with a gentle delay that adds to the rhythmic beauty of the system. Each tidal cycle takes approximately 12 hours and 25 minutes, which is exactly half the time it takes for the moon to return to the same position relative to any point on Earth's surface. This extra 25 minutes, compared to a 12-hour cycle, means that high tide doesn't occur at the same time each day, but gradually shifts later by about 50 minutes daily, creating a slow, predictable progression that connects the tides to both the moon's orbit and Earth's rotation in the most harmonious way. For those who pay attention to these rhythms, there's something deeply satisfying about this gradual shift, like watching a very slow clock that keeps perfect time with cosmic precision, never hurrying, never faltering, just maintaining its ancient cadence through day after day of reliable cycles. The sun also participates in this gravitational dance, though its influence on tides is about half as strong as the moon's, despite being vastly more massive, simply because it's so much farther away. When the sun, moon, and Earth align during new moons and full moons, their gravitational forces work together to create spring tides, not because they occur in spring, but from the Old English word meaning to jump, when the tidal range is at its greatest, with higher high tides and lower low tides than usual. Conversely, when the sun and moon are at right angles to Earth during the first and third quarter moon phases, their gravitational influences partially cancel each other out, creating neap tides with smaller tidal ranges and gentler transitions between high and low water. This monthly rhythm within the daily rhythm creates a beautiful complexity that adds layers of variation to the tidal symphony, like a piece of music, with both daily and monthly themes woven together in perfect harmony. The effects of tides extend far beyond the simple rise and fall of water levels along coastlines. They create vast tidal currents that flow like slow-moving rivers through coastal waters, carrying nutrients, sediments, and marine life in gentle but persistent circulation patterns. In some narrow bays and estuaries, these tidal currents can move at several kilometers per hour, but they do so with such predictable regularity that marine ecosystems have evolved to take advantage of their timing, with fish, birds, and other creatures synchronizing their feeding and reproductive cycles to the tidal rhythms. The mixing action of tides also plays a crucial role in ocean health, bringing oxygen-rich surface water down to deeper levels while lifting nutrient-rich deeper water toward the surface, creating a gentle but constant circulation that helps maintain the chemical balance necessary for marine life. Perhaps most remarkably, tides create their own peaceful soundscape that has been soothing human minds for as long as our species has lived near coastlines. The soft whisper of water advancing across sand, the gentle gurgle of tide pools filling and draining, the rhythmic wash of waves that arrive with slightly different timing and intensity depending on the tidal stage. This natural soundtrack operates at frequencies that research suggests can induce relaxation and even synchronize with human brainwaves, creating a natural form of meditation that requires no conscious effort, just the simple act of listening to the ocean's endless conversation with gravity. Many people report that the sound of tides and waves helps them fall asleep more easily, and there's growing scientific evidence that these natural rhythms can actually influence human circadian rhythms and emotional well-being in positive ways. The predictability of tides has made them one of humanity's first and most reliable natural clocks. Long before mechanical timepieces existed, coastal peoples could tell time by observing the tide level, plan their activities around tidal schedules, and navigate by understanding how tidal currents would affect their journeys. This relationship between human activity and tidal rhythm created some of the earliest examples of humans living in harmony with natural cycles rather than fighting against them, a practice that brought both practical benefits and a deep sense of connection to the larger cosmic forces that shape our world. Even today, despite all our modern technology, many coastal communities still organize their daily routines around tidal schedules, maintaining an ancient rhythm of life that connects them to both their local environment and the celestial mechanics of the Earth-Moon-Sun system. The most beautifully calming aspect of tides may be their absolute reliability. While weather patterns can be unpredictable and climate varies over time, tides continue their ancient rhythm with astronomical precision, following laws of physics that have remained constant for billions of years. You can calculate the exact time and height of high and low tides decades into the future with remarkable accuracy, because the gravitational forces that create them operate according to the same mathematical principles that govern planetary orbits and stellar movements. This reliability makes tides a perfect metaphor for the dependable processes that sustain life on Earth. Like heartbeat or breathing, they represent rhythms so fundamental and persistent that we can trust them to continue regardless of other changes happening around us. As you drift towards sleep tonight, you can take comfort in knowing that somewhere, on coastlines around the world, tides are following their patient schedule rising and falling with the same gentle persistence they've maintained since before life existed on land, creating an endless lullaby of reliability that connects your rest to the cosmic dance of celestial bodies moving through space with infinite grace and perfect timing. Tonight, as you breathe in and out with the natural rhythm that sustains your life, you're participating in one of Earth's most beautifully ancient and interconnected processes, a process so gentle, so patient, and so timelessly elegant that it connects you directly to sunlight that fell on prehistoric forests, to the slow exhalation of countless plants that lived millions of years before you were born. Every molecule of oxygen that enters your lungs carries with it a story that spans geological ages, a quiet narrative of photosynthesis, decay, renewal, and the endless cycling of energy and matter that has been operating with perfect consistency for over 2 billion years. The oxygen you're breathing right now was created by plants and algae through the miraculous process of photosynthesis, where solar energy is captured and used to split water molecules, releasing oxygen as what scientists call a waste product, though it's the waste product that makes all complex life on Earth possible. But here's where this process becomes truly extraordinary and deeply calming to contemplate. The sunlight that powered the photosynthesis reactions, creating the oxygen in your current breath, didn't necessarily shine on Earth yesterday, or last week, or even last year. Some of that oxygen has been cycling through the atmosphere for decades, centuries, or even millennia, having been produced by ancient forests, prehistoric algae blooms, or marine phytoplankton that lived during times when the world looked completely different than it does today. The average oxygen molecule spends about 4,500 years in the atmosphere before being consumed by respiration, combustion, or chemical reactions with rocks and minerals, which means that with every breath, you're inhaling a mixture of recently produced oxygen and ancient atmospheric gases that have witnessed the rise and fall of civilizations, the slow drift of continents, and countless cycles of climate change. This connection to ancient sunlight becomes even more profound when you consider the full journey that energy takes from the sun to your cells. Photons of light travel 150 million kilometers from the sun's nuclear furnace to Earth in about 8 minutes, where they're captured by chlorophyll molecules in plant leaves and used to power the chemical reactions that combine carbon dioxide and water into glucose and oxygen. But the glucose produced by photosynthesis represents stored sunlight energy, and when that plant material eventually decomposes or is consumed by other organisms, that stored solar energy gets released back into the ecosystem. Some of this ancient stored sunlight energy has been locked away for millions of years in the form of fossil fuels. Coal, oil, and natural gas are essentially concentrated prehistoric sunlight, captured by ancient plants and algae, and then slowly transformed by heat and pressure into the energy sources that power much of modern civilization. The oxygen cycle that sustains your breathing operates on multiple timescales simultaneously, creating a beautiful layering of ancient and recent processes that work together with remarkable harmony. On the shortest timescale, plants around the world are producing oxygen every day during daylight hours through photosynthesis, adding fresh oxygen to the atmosphere in a daily rhythm that corresponds to the sun's journey across the sky. On a seasonal scale, the total amount of atmospheric oxygen fluctuates slightly as the balance between photosynthesis and respiration changes with the seasons. During summer in the northern hemisphere, when vast forests and grasslands are actively photosynthesizing, atmospheric oxygen levels rise slightly, while during winter they drop as plant activity decreases and decomposition continues. But on the longest timescales, the oxygen in our atmosphere represents the accumulated product of billions of years of photosynthesis, with some oxygen molecules having been produced by the earliest cyanobacteria that lived in ancient seas over 2 billion years ago. This deep time perspective on breathing creates a profoundly calming connection to the continuity of life on Earth. Every breath you take links you not just to the plants growing around you today, but to every photosynthetic organism that has ever lived on our planet. The oxygen produced by a tree growing outside your window mixes in the atmosphere with oxygen that was released by ancient ferns in carboniferous swamps 300 million years ago and has been cycling through the biosphere ever since. This means that the air filling your lungs right now has been breathed by countless other organisms throughout Earth's history, by dinosaurs, by early mammals, by the first humans, by every person who has ever lived. There's something deeply soothing about this realization, a sense of being part of an unbroken chain of breathing organisms that extends back through deep time and will continue long into the future. The process that creates the oxygen you breathe also demonstrates Earth's remarkable capacity for self-regulation and balance. The amount of oxygen in our atmosphere, about 21% of all atmospheric gases, is maintained within narrow limits by the delicate balance between oxygen production through photosynthesis and oxygen consumption through respiration, combustion, and chemical weathering. This balance has remained remarkably stable for hundreds of millions of years, despite dramatic changes in Earth's climate, the evolution and extinction of countless species, and major geological events like volcanic eruptions and asteroid impacts. The stability of atmospheric oxygen levels represents one of Earth's most successful examples of what scientists call homeostasis, the tendency of natural systems to maintain equilibrium through internal regulation. What makes this oxygen cycle particularly soothing to contemplate is how it operates through the gentle, patient processes that characterize so many of Earth's fundamental systems. Plants don't rush to produce oxygen. They do it steadily, continuously, as part of their natural life processes, following rhythms of growth, reproduction, and seasonal change that have remained essentially unchanged for millions of years. The mixing of oxygen in the atmosphere happens gradually, through the slow circulation of air masses and the gentle turbulence of weather systems, ensuring that oxygen produced in one location eventually spreads around the globe to support life everywhere. Even the consumption of oxygen happens at sustainable rates. Organisms have evolved to use oxygen efficiently, and natural systems have developed mechanisms to prevent oxygen levels from rising too high or falling too low. The ancient sunlight connection extends beyond just the oxygen you breathe to encompass nearly every aspect of the energy that sustains life on Earth. The food you eat represents stored solar energy, whether it comes directly from plants that captured sunlight through photosynthesis or from animals that ate those plants. The wood that heats homes and the fossil fuels that power vehicles are all forms of ancient sunlight, solar energy, that was captured by photosynthesis and then stored for varying periods of time before being released. Even renewable energy sources, like wind and hydroelectric power, are ultimately driven by solar energy. The sun's heat creates the weather patterns that generate wind and drives the water cycle that fills rivers and creates rainfall. This connection to ancient sunlight creates a beautiful sense of continuity and connection that can be deeply calming to contemplate as you prepare for sleep. Every breath you take connects you to the sun, to ancient forests, to the long history of life on Earth, and to the gentle cycles that have sustained our biosphere for billions of years. The oxygen entering your lungs carries with it the accumulated wisdom of countless photosynthetic reactions, each one a tiny miracle of energy conversion that helped maintain the conditions necessary for life to flourish. As you relax and let your breathing slow to its natural resting rhythm, you can take comfort in knowing that this simple act of breathing connects you to processes so ancient, so reliable, and so beautifully regulated that they have continued unchanged through all of Earth's history, providing a foundation of stability and continuity that will persist long after individual lives have ended, ensuring that future generations will also breathe this same ancient sunlight, participating in the same eternal cycle of energy and life that has sustained our world since the very beginning of complex life on Earth. As you drift deeper into this peaceful evening, let your mind wander to one of Earth's most beautifully patient processes, the rock cycle, a gentle but relentless system of transformation that has been quietly recycling every grain of sand, every mountain peak, every pebble on the beach, through endless cycles of creation, destruction, and renewal for over 4 billion years. This isn't a process you can watch happening. It unfolds so slowly that entire civilizations rise and fall, while a single rock grain makes its leisurely journey from mountain to sand to new rock again. Yet this patient recycling system represents perhaps the most soothing example of Earth's infinite capacity for renewal, demonstrating how nothing on our planet is ever truly lost. Everything is simply transformed, rearranged, and given new purpose through the gentle but inexorable processes of geological time. The rock cycle begins with the slow weathering of existing rocks, a process so gradual that it makes the growth of mountains seem hurried by comparison. Water, slightly acidic from dissolved carbon dioxide in the atmosphere, seeps into tiny cracks in rock surfaces and begins the patient work of chemical weathering, gradually dissolving minerals, grain by grain, ion by ion. This process doesn't happen dramatically or violently. Instead, it operates with the quiet persistence of morning dew or gentle spring rain, working away at even the hardest granite and toughest quartzite with the kind of patience that only geological processes possess. Physical weathering adds its own gentle touch through the slow expansion and contraction of rocks as they heat up during the day and cool at night, creating microscopic fractures that gradually widen over thousands of years. Plant roots contribute to this peaceful demolition work, growing slowly into rock crevices and applying gentle but persistent pressure that can split massive boulders over centuries. Once rocks are broken down into smaller fragments through weathering, they begin one of the most calming journeys imaginable, the slow transportation process that carries rock particles from high places to low places through the patient work of water, wind, and gravity. Rivers pick up these weathered rock fragments and carry them downstream at rates measured in centimeters per year for the smallest particles, creating a gentle but persistent flow of sediment that has been operating since the first rivers began flowing on Earth. The transportation process is beautifully selective. Larger, heavier particles settle out first in quiet pools and backwaters, while the finest clays and silts continue their journey for thousands of kilometers, sometimes traveling from mountain peaks to deep ocean basins over periods spanning millions of years. This sorting action creates some of Earth's most peaceful landscapes: broad river deltas, gentle alluvial plains, and quiet lake beds where sediments accumulate with the regularity of seasonal snowfall. The deposition of these transported rock fragments represents one of nature's most methodical filing systems, with sediments settling out of rivers, lakes, and oceans in layers so regular and consistent that geologists can read Earth's history like pages in an enormous book. Each layer of sediment represents a specific time period, preserving within it not just rock fragments, but also fossils, pollen grains, volcanic ash, and other clues about environmental conditions when that layer was deposited. These sedimentary layers accumulate with incredible patience. Typical sedimentation rates range from just millimeters to centimeters per thousand years, meaning that a limestone formation only a few meters thick might represent tens of thousands of years of peaceful accumulation. The weight of overlying sediments gradually compresses the lower layers, squeezing out water and cementing the individual particles together through chemical processes that operate over millions of years, slowly transforming loose sediment into solid sedimentary rock. But the rock cycle's most remarkable aspect is how it gives these sedimentary rocks new life through metamorphism and igneous processes that operate with the same patient persistence as the weathering that created them in the first place. When sedimentary rocks are buried deep enough or subjected to the slow pressure of tectonic forces, they begin to transform into metamorphic rocks through processes that unfold over millions of years. The transformation happens so gradually that the original rock maintains its overall structure, while its minerals slowly recrystallize, creating new patterns and textures without melting or breaking apart. Limestone transforms into marble, sandstone becomes quartzite, and shale metamorphoses into schist through these gentle processes of heat and pressure that demonstrate Earth's incredible capacity for patient renovation. The ultimate transformation in the rock cycle occurs when rocks are heated enough to melt completely, creating magma that can eventually cool and solidify into igneous rocks, completing the cycle and beginning it anew. This melting process typically occurs deep within the Earth, where temperatures reach hundreds or thousands of degrees. But even at these extreme conditions, the process unfolds with geological patience. Magma chambers beneath the surface can exist for hundreds of thousands of years, slowly cooling and crystallizing as different minerals form at different temperatures, creating the beautiful patterns and textures found in granite and other igneous rocks. When this magma eventually reaches the surface through volcanic activity or is exposed by erosion, it begins the weathering process all over again, starting a new cycle that can continue indefinitely. What makes the rock cycle so profoundly calming to contemplate is how it demonstrates that nothing on Earth is permanent, yet everything is continuous. The sand on a peaceful beach today was once part of an ancient mountain range, and millions of years from now, it will be compressed into new sedimentary rocks that might themselves be transformed into metamorphic rocks or melted into magma. This constant transformation happens so slowly that it provides a sense of both change and stability. The materials are always moving through the cycle, but the process itself remains constant, reliable, and endlessly renewable. Every landscape on Earth, from the highest peaks to the deepest valleys, represents a temporary arrangement of materials that are continuously being recycled through this patient system. The rock cycle also reveals Earth's remarkable efficiency as a recycling system. Virtually nothing is ever wasted, and even the most exotic materials eventually find their way back into the cycle. Rare minerals formed under extreme conditions deep within the Earth can be brought to the surface through geological processes and then weathered into common sediments that get incorporated into new rocks. Organic materials from ancient life forms become part of sedimentary rocks, then can be metamorphosed or melted and reformed into entirely new types of rocks, carrying the chemical signatures of life into Earth's geological record. This integration of biological and geological processes demonstrates how the rock cycle connects all of Earth's systems in a web of relationships that operate across deep time. Perhaps most remarkably, the rock cycle operates as a kind of planetary memory system, preserving information about Earth's history while continuously creating new opportunities for that information to be discovered and interpreted. Rocks formed billions of years ago still exist today, carrying within their mineral structures records of ancient atmospheres, climates, and life forms. Yet the cycle ensures that this ancient information doesn't just sit static. It gets moved around, exposed by erosion, buried by sedimentation, and transformed by metamorphism in ways that continually reveal new chapters of Earth's story. As you settle into sleep tonight, you can take comfort in knowing that the rock cycle continues its patient work all around you, slowly but persistently, recycling the materials of our planet through processes so gentle and reliable that they have operated without interruption for billions of years, creating and maintaining the solid foundation that supports all life on Earth, while demonstrating the profound peace that comes from systems that work in perfect harmony with the rhythms of deep time. As you drift deeper into this tranquil evening, allow your awareness to sink gently below the surface of the Earth, down through layers of soil and rock, into the hidden realm of groundwater aquifers, vast underground rivers, and lakes that flow so slowly through the darkness that a single drop of water might spend thousands of years on its underground journey before ever seeing sunlight again. These subterranean waterways represent perhaps the most patient and meditative aspect of Earth's water cycle, moving through underground spaces with such gentle persistence that they create some of the most profoundly calming processes on our planet. Unlike the rushing streams and rivers we see at the surface, groundwater flows at rates measured in centimeters per day or even per year, creating underground circulation patterns that operate on timescales so vast they make human history seem like a brief moment. The journey of groundwater begins at the surface during the quiet moments of rainfall or snowmelt, when water seeps gently into the soil through a process called infiltration that happens with the patience of centuries. This water doesn't rush downward in a hurry. Instead, it percolates slowly through spaces between soil particles and rock grains, following pathways that wind and meander through the underground landscape like the most unhurried hiking trail imaginable. The speed of this downward movement depends on the type of soil and rock. In sandy soils, water might move a few centimeters per day, while in dense clay or solid rock, the same water could take months or years to travel the same distance. This slow infiltration creates what hydrologists call the unsaturated zone, where air and water coexist peacefully in the spaces between soil particles, maintaining the perfect moisture balance that allows plant roots to access water while still providing the drainage necessary to prevent waterlogging. Eventually, this slowly descending water reaches the water table, an invisible underground boundary, where all available spaces in soil and rock become completely filled with water, creating the saturated zone that contains Earth's vast groundwater reserves. The water table isn't a sharp line, but rather a gentle transition zone that rises and falls with the seasons, responding to patterns of rainfall and drought with the same patient rhythm that characterizes all groundwater processes. Above the water table, plant roots access soil moisture for their growth, while below it, water accumulates in underground formations called aquifers, layers of permeable rock or sediment that can store and transmit groundwater like underground sponges. These aquifers range from shallow formations just a few meters below the surface to deep fossil water aquifers that lie hundreds or even thousands of meters underground, containing water that fell as rain during entirely different climate periods in Earth's history. The flow of groundwater through these aquifers represents one of nature's most serene examples of hydraulic patience. Water moves from areas of higher elevation and pressure toward areas of lower elevation and pressure, but it does so through such circuitous underground routes that the journey can take centuries or millennia to complete. In a typical shallow aquifer, groundwater might flow at rates of 1 to 10 meters per year, which means that water entering the ground today might not emerge at a nearby spring or river for decades. In deeper aquifers, the flow rates can be even slower, with some groundwater systems having residence times, the average length of time water spends underground, of thousands or tens of thousands of years. This means that some of the groundwater being pumped from deep wells today originally fell as precipitation during the last ice age. When woolly mammoths roamed the earth, and human civilization had not yet begun. These ancient waters carry within them a chemical record of their long underground journey, having slowly dissolved minerals from the rocks through which they flowed over millennia. The process of chemical weathering that occurs as groundwater interacts with rock formations is so gradual that it's measured in terms of parts per million accumulated over thousands of years, creating the distinctive mineral content that gives different groundwater sources their characteristic taste and chemical properties. Some groundwater emerges from deep aquifers with high mineral content, having had eons to slowly dissolve calcium, magnesium, iron, and other elements from surrounding rocks, while other groundwater from shallow, rapidly recharged aquifers remains relatively pure, having had less time for chemical interaction. This chemical evolution of groundwater demonstrates how even the most basic processes of solution and dissolution operate with geological patience, changing water chemistry so gradually that the process is essentially invisible to human observation. The discharge of groundwater back to the surface occurs through equally gentle processes that complete the underground portion of the water cycle with the same unhurried grace that characterizes all groundwater movement. Springs represent the most peaceful manifestation of this discharge, where groundwater that has been flowing underground for years or decades finally emerges at the surface through natural openings in rock or soil formations. The flow rate of springs reflects the patient underground journey that preceded their emergence. Some springs flow steadily year-round, fed by large, stable aquifers, while others fluctuate seasonally as they respond to the gradual recharge and depletion cycles of their underground water sources. Many springs maintain remarkably constant temperatures throughout the year, reflecting the thermal stability of the underground environment where their water has spent so much time insulated from surface temperature variations. Groundwater also discharges invisibly into rivers, lakes, and wetlands through a process called baseflow, where underground water seeps slowly upward through the bottom sediments of surface water bodies. This baseflow represents the stable, reliable component of river flow that persists even during dry periods when surface runoff has ceased, demonstrating how the patient underground water storage system provides crucial support for surface ecosystems. During dry seasons, many rivers and streams are sustained entirely by this gentle upwelling of groundwater, creating the perennial flow that maintains aquatic habitats and provides water for wildlife, even when no rain has fallen for months. The temperature stability of groundwater discharge also helps moderate the temperature of rivers and lakes, providing cool water refugia for fish and other aquatic organisms during hot summer months. The interaction between groundwater and surface water creates some of Earth's most peaceful and stable ecosystems, including wetlands, springs, and riparian forests that depend on the consistent, gentle supply of groundwater discharge. These groundwater-dependent ecosystems often serve as oases of tranquility in the landscape, maintaining green vegetation and flowing water even during periods of drought when surrounding areas become dry and dormant. The plants and animals that inhabit these environments have evolved to take advantage of the reliable, consistent water supply that groundwater provides, creating communities that remain stable and productive across seasons and years. Many of these ecosystems also serve as natural water treatment systems, where the slow flow of groundwater through soil and plant root systems removes pollutants and excess nutrients, demonstrating how the patient processes of underground water movement contribute to overall environmental health. Perhaps most remarkably, groundwater aquifers serve as Earth's largest freshwater storage system, containing more than 30 times as much freshwater as all the world's rivers and lakes combined. This vast underground reservoir represents the accumulated result of countless rainfall events over thousands of years, stored in rock formations with such reliability that many aquifers have provided consistent water supplies for entire civilizations throughout human history. The recharge of these aquifers happens so slowly and steadily that they represent some of Earth's most stable and dependable resources, though their slow recharge rates also make them vulnerable to overuse if water is withdrawn faster than natural processes can replenish it. As you settle into sleep tonight, you can take comfort in knowing that far beneath you, this ancient system of underground rivers continues its patient circulation, moving water through darkness with the same gentle persistence it has maintained for millions of years, storing and slowly releasing the fresh water that sustains life on Earth's surface, while operating according to the unhurried rhythms of deep time that connect today's precipitation to tomorrow's springs in an endless cycle of underground patience and surface renewal. As we reach the final moments of our peaceful journey together tonight, let your awareness settle into perhaps the most fundamental and comforting of all Earth's gifts, gravity itself, the gentle, invisible embrace that holds you securely against our planet's surface, while creating the perfect conditions for life to flourish in the most serene and stable way imaginable. This isn't the dramatic gravity of science fiction, pulling spacecraft into black holes or creating impossible challenges for heroes to overcome, but rather the quiet, constant, nurturing force that makes every moment of your existence possible, holding your feet on the ground, keeping the atmosphere wrapped around Earth like a protective blanket, and maintaining the delicate balance that allows your heart to pump blood, your lungs to breathe air, and your mind to drift peacefully toward sleep. Earth's gravity is perfectly calibrated for life, not too strong to crush delicate organisms, not too weak to allow essential gases to escape into space, creating what scientists recognize as one of the most remarkable Goldilocks conditions in our solar system, where everything is just right for the gentle processes that sustain life. The strength of Earth's gravity, measuring 9.8 meters per second squared, represents millions of years of cosmic fine-tuning that created exactly the right conditions for water to remain liquid at the surface, for atmospheric pressure to stay within the narrow range that allows breathing to occur effortlessly, and for the gentle circulation patterns in oceans and atmosphere that distribute heat and moisture around the globe with such consistency that complex ecosystems can develop and thrive. This gravitational field extends far beyond the surface, creating what scientists call Earth's gravitational well, an invisible sphere of influence that captures and holds our moon in its patient orbital dance, maintains the precise distance that creates our stabilizing tides, and keeps our atmosphere from drifting away into space the way Mars lost its atmosphere billions of years ago. The moon's gravitational interaction with Earth creates the tidal forces we explored earlier, but it also serves as a gravitational partner that stabilizes our planet's rotation, preventing the dramatic wobbles that would make climate chaotic and life difficult to sustain. What makes Earth's gravitational embrace so profoundly calming is how completely reliable it is. Unlike weather that changes daily, or seasons that shift gradually, or even the slow geological processes that unfold over millennia, gravity provides a constant background of stability that never varies, never takes a break, never requires maintenance or attention. Every object on Earth, from the smallest grain of sand to the largest mountain, from every drop of water in the oceans to every molecule of air in the atmosphere, experiences exactly the same gravitational acceleration, creating a universal field of equality where the laws of physics apply consistently everywhere and at all times. This consistency allows for the predictable behavior of natural systems. Water always flows downhill, objects always fall at predictable rates, and the overall structure of our planet remains stable enough for slow, gradual processes like erosion, sedimentation, and biological evolution to operate over the vast timescales necessary for complex life to develop. The way gravity shapes every aspect of Earth's structure and processes creates some of the most soothing patterns in nature. The gentle curves of river valleys carved by water following gravitational gradients. The sorted layers of sedimentary rocks deposited as particles settled according to their weight. The spherical shape of our planet itself, formed as gravity pulled matter inward during Earth's formation 4.6 billion years ago. Even the circulation of air in our atmosphere follows gravitational principles, with denser cold air sinking gently, while less dense, warm air rises, creating the circulation patterns that distribute solar energy around the globe and maintain the climate stability that makes Earth habitable. The formation of clouds, the fall of rain, the flow of rivers, the accumulation of snow on mountain peaks, and the slow drift of glaciers all represent gravity working in harmony with other natural forces to create the beautiful, life-sustaining processes that operate continuously around us. Gravity also creates the perfect environment for the biological processes that sustain life. providing the gentle but persistent force that allows plant roots to grow downward toward water and nutrients, while stems and leaves grow upward toward sunlight. The circulation of blood in your body depends on gravity to help return venous blood to your heart, while your inner ear uses tiny gravitational sensors to maintain balance and spatial orientation. Even the way your lungs function depends on gravity to help with the gentle settling of air and the efficient exchange of oxygen and carbon dioxide that keeps your body functioning optimally. The peaceful rhythm of your breathing, the steady beat of your heart, and the quiet neural activity that allows your mind to process thoughts and emotions all operate within the stable gravitational field that makes complex biological processes possible. As you settle deeper into relaxation tonight, you can take profound comfort in knowing that gravity provides the ultimate foundation of security. No matter what changes occur in your daily life, no matter what challenges or uncertainties you might face, the gravitational field that holds you safely on Earth's surface will continue with absolute reliability, providing the stable foundation that makes all other experiences possible. This gravitational embrace connects you not just to Earth's surface, but to the entire cosmos. The same gravitational forces that keep you grounded also guide the orbits of planets around the Sun, hold solar systems together within galaxies, and shape the large-scale structure of the universe itself. Every moment of your existence unfolds within this vast gravitational web that connects your peaceful rest tonight to the cosmic processes that have been operating for billions of years and will continue for billions more. The most beautiful aspect of Earth's gravitational embrace may be how it allows for both stability and change, providing the constant foundation that makes life possible while still permitting the gentle movements and transformations that create the dynamic, evolving world we experience. Gravity holds the oceans in their basins while allowing tides to flow, keeps the atmosphere close to Earth while permitting weather systems to move and change, and maintains the overall structure of our planet while allowing for the slow geological processes that continuously reshape the surface. This balance between stability and change, between security and possibility, reflects the deeper wisdom embedded in natural systems. The understanding that true peace comes not from rigid unchangingness, but from reliable processes that can adapt and respond while maintaining their essential character. Outro. As our gentle journey through Earth's most calming processes draws to a close, we've traveled together through the magnetic heartbeat that protects us, the patient ocean currents that regulate our climate, the slowly growing mountains that demonstrate nature's persistence, the carbon cycle that represents our planet's deep breathing, the crystalline foundations forming beneath us, Earth's graceful wobble dance through space, the quiet symphony of tides, the ancient sunlight in every breath we take, the patient recycling of rocks through geological time, the underground rivers flowing through darkness for centuries, and finally, the gravitational embrace that holds all of these beautiful processes together in perfect harmony. Each of these phenomena operates with the kind of patience, consistency, and gentle persistence that can teach us profound lessons about finding peace in our own lives. They remind us that the most powerful processes often work quietly in the background, that true stability comes from systems that can adapt while maintaining their essential character, and that we are part of something much larger and more enduring than our daily concerns. Tonight, as you drift toward peaceful sleep, You do so supported by all of these ancient, reliable processes that have been operating since before life existed on Earth and will continue long after our individual stories have ended, providing a foundation of cosmic stability and continuity that can offer profound comfort to anyone willing to pause, breathe deeply, and remember their connection to the patient rhythms that sustain our beautiful planet. Thank you for joining our Sleepy Cosmoz family on this journey through Earth's most soothing secrets. May these gentle Earth processes continue to bring you peace, wonder, and the deepest, most restful sleep, knowing that you are held safely within the embrace of a planet that has been perfecting the art of nurturing life for over 4 billion years. Sweet dreams, cosmic family, and remember that every breath you take connects you to the infinite patience and beauty of our amazing Earth.